Hello everyone, this is Prashanth. Let's continue with the last lecture. In the last lecture, just I have completed two main controlling hardware based on the IoT application. That is connecting LED, and second one is buzzer. So how the device will how the circuit will form on the breadboard. Just before that, just we have some components like LED, connecting wires, microcontroller, like that we have some components. After that, to make the connections on the breadboard and write the code for to dump the microcontroller, and it will give 1 second delay also for blinking of the LED. So after that, after executing that code dumping to the microcontroller, the output will come in on the LED. Just the LED on and off blink off for every 1 second. So that is the one part, one device under the controlling hardware and sensor. The second one is buzzer. Buzzer, it will give beep sound for every 0.5 second. For every 0.5 second, same process as like LED to make the connections on the breadboard. Like connecting write the program and the program dumping to the microcontroller, like that. Just we have studied about these two type of controlling hardware with the real time case. So now we move entering into the second part of introduction to controlling hardware and sensors. That is the before that, first we have to know the course objectives. Here the students will try to learn to provide students with a comprehensive understanding of IoT concept, technology and applications. We already know these course outcomes. We already explained in the last lecture also. To equip students with practical skills, hardware interfacing, sensor integration and IoT system development, like that. And to familiarize students with network management and cloud computing techniques relevant to the IoT. We already know. Just we reach the higher level of Bloom abstraction level, that is creating critical thinking level, problem solving abilities in designing the implementing IoT solutions across the various domains. So this is the course objectives. The students will try to learn something. Next, course outcomes. So after successful of the course, the student should be able to different activities on the IoT device, like evaluate IoT applications, communicate and collaborate effectively participation, and adapt to emerging IoT trends. So in terms of IoT, evaluate IoT applications. For that, just we have developed the to protect the scalability of the system, scalability and reliability and cost effectiveness of the system, and communicate and collaborate effectively. Just we can communicate with another person or another any other, and just collaborate with any company. Like that, it should be able to they collaborate effectively in interdisciplinary teams to solve complex and IoT related. Just we can communicate with other interdisciplinary departments also. We can solve some complex problems, like that. So that is comes under communicate and collaborate effectively. The last one, adapt to emerging IoT trends. IoT nowadays, just we are using common IoT device, but we don't know this is IoT device. This is the what is, we don't know the function of what the function inside is going on inside the device. So that is the adapt to emerging IoT trends. So next one, objectives, data and data acquisition and monitoring system, gathering information and tracking and analyze. Gathering information is nothing but the main agenda of IoT is gathering information from the different sources. After gathering, just it can analyze, it can process the data to the required destination part, and track and analyze. By continuously monitoring data, we can track the changes over time, identify trends. This allows us to understand how a system is functioning and anticipate potential problems. Like that, we have two objectives under data acquisition and monitoring. So next one, under system automation and control, influence the environment, just we can collect the some input parameters like to certain hardware components called actuators can be controlled to physically change the environment. For example, include turning on lights, opening values, starting motors by using the sensor data as input like that. It is the influence of the environment. Next, optimize the performance. So here control systems can use sensor data to adjust to actuator settings in real time. This allows for automatic optimization of things like temperature, efficiency, and resource usage. So these are the some input parameters, very important. Improve user experience also. In many cases, the controlling hardware creates a more convenient or user friendly experience. For example, a thermostat automatically adjusts heating based on sensor readings for temperature. So this is the second type of objectives in system auditing. The next one, increased efficiency, improved safety, enhanced decision making, greater convenience and comfort. These are the some objectives. Just you can increase the efficiency, automate task, optimizing process can save time, energy and resources. Like improved safety, control systems can prevent accident by taking corrective actions based on sensor readings. Enhanced decision making, data collected from sensors can provide valuable insight to inform better decision making. The last one, greater convenience and comfort. The convenience also very easy to interact with any other devices. Automated system can create a more comfortable for user friendly environment. So these are the remaining four objectives: increase efficiency, improve safety, enhance decision making, and greater convenience to and comfort. Next one, switching high power devices with transistors, the real time example. In that, just we discussed about only in last class connecting LED and buzzer. So here switching high power devices with transistors. So we already know transistor is nothing but transfer plus resistor. Just it is used for switching purpose. It is a three terminal device, like the device is like that. It is having three terminal, emitter, base, collector. Like that, it is one electronic device. In the principles of IoT, the transistor crucial components for controlling high power devices. It cannot directly driven by the low power outputs of microcontrollers. Here's how transistor used for switching in IoT applications. So that is the switching high power devices with transistors. Understanding of transistors, the input transistor act as an electronic switch. It has three terminals: base, emitter, collector. Just we already know this is the emitter, this is emitter, this is base, this is collector. So the output will be collected from the collector only. Just when we are giving input to the base, the emitter to the just to maintain the stabilization. By applying a small voltage to the base terminal, you can control the flow of much larger current between the collector and emitter terminal. So this is the some explanation part regarding how transistor will work. Types of transistor we already know. Here we have two types of transistor, unipolar and bipolar junction transistor. Unipolar and bipolar junction transistor. What is the difference between unipolar and bipolar? Here types of transistor, bipolar junction transistor, that is BJTs. These come in two types, NPN and PNP transistor. The basic principle remains the same, but the biasing voltage applied to the base for switching is different between NPN and PNP types. The function is same, but based on the application, just we may use only NPN transistor. Why? Because we are using to design any electronic circuit. Mostly we are preferring NPN transistor only as compared with PNP transistor. We have a lot of three main differences among these three, why we are using NPN transistor, that we'll discuss later. And field effect transistor, here unipolar junction transistor, another common type, and also function as electronic switches. This is and electric field to flow of control like that. These are the unipolar. Just to why it is the difference between unipolar and bipolar junction transistor. Generally, the unipolar junction transistor defines it is known as unipolar is nothing but the flow of direction of current through the based on either holes or current. So that is unipolar. But bipolar, in bipolar, the current flow based on the flow of either current or both current electrons and holes. So that is the main difference between unipolar junction transistor and bipolar junction transistor. So bipolar junction transistor consists to NPN and PNP transistor. Unipolar junction transistor different types. Also one of that is field effect transistor, that is shortly FET. So next, switching high power devices like SCR. Microcontrollers typically operate at low voltages and it cannot provide enough current to directly power high power devices, motors, solenoids, lamps like that. The transistor act as intermediates. The microcontroller send a small control signal to the base of the transistor. This control signal allows a much larger current to flow from the power source through the collector and emitter of transistor, turning on the high power devices. So this is about the switching high power devices like that one. Next, applications in IoT here, controlling motors, switching lights, solenoid activation. So here under controlling motors, transistor can be used to control DC motors based on the direction and speed, to turn off on off AC motor for devices like pumps or fans. So this is one of the application in IoT under controlling motors. The second one, switching lights. High power LEDs or incandescent lamps can be controlled with the transistors, enabling dimming or on-off functionality based on sensor data or user commands. So that is the second application, switching lights. Second one, solenoid activation. Transistor can control solenoid used in valves or other actuators in IoT system. So that is the third one. Next to safety consideration. What are the safety consideration? Working with main power supply require caution, following electrical safety guidelines. It's recommended to use pre-built driver modules or consult a qualified electrician for high voltage applications. Transistor have current or voltage limitations. Choose a transistor with appropriate ratings to handle the specific device you are controlling. So the last one, heat dissipation is a concern. Depending on the power being switched, a heat sink may be required for on the transistor to prevent overheating and damage. So that is the important factor in order to maintain the transistor. Heat sink just to be maintained. So these are the some safety considerations by using high power switching devices. And learning resources here. There are many online tutorials or resources that explain the transistor basics and how to use them in the circuits we already know. Searching for transistor as a switch or BJT for beginners will provide you a good starting point. As per my knowledge, one book are available in the library. That is the Millman's and Hackins electronic device and circuit. In that there is a clear explanation for transistor, how the transistor will operate, how many regions are available, and what are the applications, what are the common base, common transistor, common collector, common emitter. Some configuration techniques also available to explain that Millman's and Hackins and Labart. William Labart. And starter kits often include transistor components to experiment with the basic switch circuits also. By understanding how transistor work, you can unlock the ability to control high power devices in your IoT projects, enabling wide range of functionalities and interactions with physical world. So that is the some learning resources. And the controlling AC power devices with relays here. The first one, switching high power devices. Next, controlling AC power devices with relays. So here, absolutely controlling AC power devices with relays is a fundamental concept in IoT applications where you need to interact with the devices operating on main power supply. Here's breakdown of how it is works. The role of relays. What are the role of relays? So here a relay is a electromechanical switch that uses a high power control signal to control a high power circuit, and it has a coil and contacts. When a voltage is applied to the coil, it generates a magnetic field that pulls in a metal armature, and this armature physically opens a closed set of contents, interrupting or allowing current flow in the high power circuit. So these are the some roles of relays. Why use relays in IoT? The main significance of relays by using in IoT, here safety and power handling. The main two advantages to use relays in IoT. What the safety? Safety is nothing but it typically operated to low ranges 3.3 volts to 5 volts. Just our mobiles batteries also having this range 3.5 to 5 volts. It cannot handle high voltages, 120 volts or 240 volts like that of main power. The relays provide isolation between the low power circuit and high power circuit. It maintains high power AC circuit and low power AC circuit. So that is the safety. Under safety, why we are using relays in IoT. And power handling. Power relays can handle much high currents than transistor, making them suitable for controlling power AC devices like inside appliances or motors. So these are the two reasons why we are using relays in to develop the IoT projects. And types of relays. How many types of relays here? SPDT and DPDT. Single pole double throw and double pole double throw. So here this have one common contact, normally open NO and normally closed contact. The control signal determines which contact connect to the common. So the next one, double pole double throw. These have two sets of SPDT contacts, allowing independent control of two separate AC circuits with a single control signal. So these are the two types of relays. Next one, using relays in IoT project. The reason we already discussed in the last slide: connect to the controlling circuit and connecting the AC power circuit and microcontroller code. So here the control circuit connects the microcontroller output pin to the relay coil through the current limiting resistor, that is the connecting the control circuit, and connecting the AC power circuit. Under following safety precautions, connecting the AC power source to the relays, high power contacts. The device you want to control connect to the other terminals of the high power contacts. The microcontroller code, the code sends a high signal to the control pin to activate the real code. So this is the microcontroller code. Safety precautions. Working with AC power is dangerous. If you are not comfortable with electrical wiring, consult a qualified electrician. Just you can contact. Always double check your connections, whether it is fit or not, and user relays with voltage current ratings exceeding the AC devices you are controlling, and considering using pre-built relay modules that integrate essential components like optocouplers for add safety isolation. So benefits of relays in IoT: enables the safe, reliable control of AC device from low power to microcontrollers, and offers isolation between control power circuits, protecting your microcontroller, and provides high current handling capabilities compared to the transistor. These are the benefits of relays in IoT. Learning resources. We have so many resources available in online. Among that, controlling AC device with relays or IoT relay modules. Just you can type in Google. Just automatically it display the required information based on the controlling hardware and sensor. That is relays. By understanding relays, following safety guidelines, you can incorporate AC power control into your IoT devices, allowing them to interact with a wide range of devices in the real world applications. So these are the learning resources. So these are the two here in this lecture, controlling switching power devices using transistor. Like the second one, role of relays used in IoT. So these are the two devices here. Remaining continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.